Hello, my name's Kevin Large and I shall be your instructor for this video. This is the third in a series of videos where we're building a complex evolving network, getting more and more complicated and detailed with every single video. In this video, video number 3, we're going to look at IP addressing. Static IP addressing and also automatic IP addressing using the Dynamic Host Configuration Protocol, DHCP. And we'll have a little look at testing connectivity as well with ICMP. Okay, so we're going to start where we left off in video 2. And this is how the network looks. The last thing we did in video 2 was we created 4 sub-interfaces on Fast Ethernet 00, one for each of the VLANs, VLANs 10, 20, 30 and 40. We configured encapsulation .1q for the trunk links. So we've got a trunk link running between the switches, and we've also got a trunk link running up from the left-hand switch, SW1, into the router sub-interfaces. Now, we also configured the highest usable IP address on each of these subnets as the default gateway for its respective sub-interface on the router. So far, sub-interface Fast Ethernet 00.10, which is the sub-interface for the VLAN 10 sales, we would use the highest IP address in the 172.16.10.0 subnet. Now, being as we have a /24 mask, 32 subtract 24 gives you 8. 2 to the power of 8 is 256. So there's 256 addresses ranging from .0, which is the network, all the way up to .255, which is the broadcast. So if we want to use the highest usable IP address, we can't use .255 because that's the broadcast, so it will be .254. So what I'm going to do, I'm just going to put those default gateway addresses onto the diagram. So we will say VLAN 10 DG, we'll use DG for default gateway, 172.16.10.254, and of course that did have a /24 mask on it, has to have the same subnet mask. Okay, I'll tidy those all up in a second or two. VLAN 20, that is the 172.16.11.0 network with a /26 mask. /26, so 26 ones in the subnet mask. How many zeros? Well, let's see, 32 minus 26 is 6. So 6 are left of zeros. 2 to the power of 6 will give us the number of addresses. 2 to the power of 6 is 64. Minus the network and broadcast, 62 usable addresses. Okay, so that will range from 0 to 63, 0 being the network, 63 being the broadcast. So 62 would be our highest IP address. Therefore, VLAN 20, the default gateway, will be 172.16.11.62 with a /26 mask. Okay, speeding up a little bit, we've got 172.16.11.64 with a /27 mask. 32 minus 27 is 5. 2 to the power of 5 is 32. Minus the network and broadcast is 30, so 30 usable addresses. So let's see, the easiest way of working out the default gateway is actually to look at the next network up. The next network up is 96. Subtract 1 will be the broadcast for the management network. That would be 95. Subtract another one would be 94. So 172.16.11.94 /27. Okay. Now the sales VLAN. Oh, hold on. Haha. Let's make sure we do that properly. I haven't specified which VLAN that is. VLAN 40 DG. Okay, that's better. Actually, no, it's not, because it's not VLAN 40. It's VLAN 30. Documentation is so important. It's the last thing people want to think about, but it's so important to get the documentation right. So VLAN 40 DG, default gateway, is 172.16.11. Let's think this one through. Right, so we start at 96. It's a /28. 32 minus 28 is 4, so we've got 4 zeros in the subnet mask. It's the zeros that are the hosts. 2 to the power of 4 is 16. This is going up in blocks of 16 with the /28 mask. So if it starts at 96 and goes up in a block of 16, the next subnet up would be 96 and 16 is 112. The broadcast would be 111. The default gateway would be 110. Okay, looking good. So we've got 4 default gateways, 4 IP addresses. 4 IP addresses all on the same interface, all in the same cable. It's kind of crazy that, isn't it? Of course you can only do that because you're using sub-interfaces. That's better, isn't it? VLAN 10, 10254, VLAN 20, 1162, VLAN 30, 1194, VLAN 40, 11110. All with different subnet masks. This is known as variable length subnet masking. Okay, if I highlight all of those for a second and just move them slightly across, if I hover over that router, we should hopefully see those addresses. 10254, 1162, 1194, 1110, all with the correct masks. How useful is Packet Tracer? It's such a great tool. Okay, now we need to do some more addressing. Let's have a think about the servers. Well, servers, should they have static or automatic IP addressing? They should definitely have static addressing, shouldn't they? The server always has to be located at a specific place. You don't want your server's IP address to be moving around. So we will configure a static IP address on the server. This is the 172.16.11.96 VLAN. Sorry, 172.16.11.96 subnet. VLAN 40. Let's use the first IP address. That will be 97. Okay, so we click on the server, go to config. Actually, there's 2 ways of doing it. There's a quicker way. We'll go to desktop, go to IP configuration, make sure we've got static selected, and then just type the number in. 172.16.11.97. Okay, I'm going to hit tab. Now when I hit tab, it guesses that I want a 255.255.00 mask, /16 mask. The reason it guesses that mask is it looks at the first octet, which is 172, recognises that that's a class B address, and tries to put the default class B mask of /16 or 255.255.00. This is of course not the mask we want. We are using a /28, which is 255.255.255. So there's 8, 16, 24 bits and 4 bits from the 4th octet, 240. 8, 16, 24, 28 bits. Okay. A default gateway just over there, VLAN 40, default gateway 11.110. 172.16.11.110. Okay, and we need a DNS server as well. That's an interesting point. Who should we use for a DNS server? Let's use this DNS server out on the internet. It's currently not configured as a DNS server, but we'll do that in a later video. 10.10.10.0 network /24. This machine is 10.10.10.1. Okay, that's as good a DNS server as any. 10.10.10.1. Okay, looking good. I'm just going to click in this next box down just to make sure everything's selected and close the window. How can I check to make sure I've got the correct IP address? Command prompt, IP config. Okay, looking good. I have 172.16.11.96 97, the first IP address on the sales subnet, a subnet mask of 255.255.255.240/28, the default gateway of 172.16.11.110. VLAN 40 default gateway 172.16.11.110. Perfect. If I actually do ipconfig /all, you can see some more information. You can see that I've got the correct default gateway of 10.10.10.1. Sorry, the correct DNS server of 10.10.10.1. This IP address here is a local link IP address. That's automatically generated. Starts with FE80, so we don't need to worry about that. And here we have the MAC address of the server. 48-bit number represented in hexadecimal. 12 hexadecimal digits. 48 bits. Each hexadecimal digit represents 4 binary bits. Okay, looking good. So there's our server statically configured. And while we're at it, we'll configure the server on this end as well. So it's quick and easy to do. 10.10.10.1 subnet mask guesses it's a /8 because it looked at the first octet. That is a class A address with 10 in the first octet, so it's tried to put a default class A mask on it, which is incorrect of course, because we're using variable length subnet masking. So we will put the correct /24 mask on, and then we'll put our default gateway, which will be the IP address of our router, which is 10.10.10.254. 10.10.10.254. Looking good. And the DNS server, that's itself. 10.10.10.1. That'll do. Just click in that box there. Do a check. I always like to check to make sure everything's gone in correctly. ipconfig /all. Excuse me. 10.10.10.1. Yeah, that's fine. Absolutely spot on. Okay. Now, while we're at it, let's just configure the interface across the internet. Because we're doing IP addressing, so let's do some IP addressing and configure the interface across the internet. So we'll do which side? We'll do the service provider side first, because we haven't looked at that router yet. So I'm going to click on the service provider router. First of all, I'm going to actually type ISP, Internet Service Provider. Okay, that way we know what we're looking at. A little bit of IP addressing quickly on the service provider. Just say no to set up configuration dialog. Enable conft hostname ISP. We'll be using the abbreviations quite a lot, I think, now. Okay, so what do we want to do here? Let's have a look. We want to go into the Fast Ethernet 00 interface first of all and give it the IP address of 10.10.10.254. Interface Fast Ethernet 00 IP add. That'll work. Abbreviate it. 10.10.10.254. It'll understand IP address is IP add because it's a perfectly valid abbreviation. I've not shortened it so much so that it's an ambiguous number of letters. Okay, 255.255.255.0. Job done. No shutdown. Watch the green lights. There's the green light. Bit hard to see the green light with a blue background, but it's definitely there. Orange light on the other end while spanning tree sorts itself out. I'm going to type exit. I'm going to go into the serial link now. Interface serial, and that was 0/0/1. Again, if you're not sure, you just hover over the button and you'll see which serial link it is. I'm going to put an IP address of 88.40.12.2. 88.40.12.2. Nice Class A public IP address. with a /30 mask, so that's 255, 255, 255, and the 6 bits from the 4th octet. The first 6 bits gives us 252. Now, this is the service provider end. I need a clock rate. Clock rate. How good is that? What command puts the clock rate on? Go into the interface, clock rate. What speeds have we got? Use the question mark. Gives us the speeds. I'm just going to put 128,000 on. Now bear in mind the clock rate is measured in bits per second. Bits per second. Okay. The clock rate controls the speed of that link, really. I'm going to also type bandwidth. Now the bandwidth is measured in kilobits per second, so thousands of bits per second. So if I've got a clock rate of 128,000, I need to divide that by 1,000 to give me the bandwidth. So 128,000 divided by 1,000, of course, is 128. So whatever your clock rate is, because that's in bits and your bandwidth's in kilobits, just divide your clock rate by 1,000. What's the bandwidth used for? Well, the bandwidth's used by routing protocols. If you're running a routing protocol, and a routing protocol's job is to communicate between the two routers, exchange networks, try to work out the fastest way around the network using metrics or measures of how good the links are. Very, very important routing protocols, but they use the bandwidth to calculate the metrics, certain routing protocols. But it's really the clock rate that controls the speed. Okay, so what have we got left to do? Only a no shut. No shut, the opposite of shut. Shutdown shuts down the link, no shut brings it up. Okay, that's good. So we've typed no shutdown, and completely the opposite of what we expected to happen has happened. No shutdown, bring the link up. What's it done? Completely the opposite, brought it down. There's a reason for that though. A serial link will not come up unless both ends are correctly configured, and currently the other end is not correctly configured. If I do a Control Z and a WR and do a show IP interface brief, you'll notice on the serial link it doesn't say administratively down, it just says down. Big difference. Administratively down means I have not told it to switch on. I have not issued no shutdown. Down on the other hand, that means I have told it to switch on. It just can't switch on at the minute because the other end isn't configured correctly. Okay, this end will come up once the other end's configured, which we'll do now. So into the customer side router, and let's just move it so as we can see the link go on. Enable conf t int. How much can I shorten this down? S 0/0/0/0. That should do it. So we're going to interface serial 000. IP add, hit tab. 88 40 12.1 255 255 255 252. This is not the service provider end. This is the DTE. It's only the DCE that needs the clock rate, the clock end. This is the DTE. It does not need the clock rate. So we don't need to type clock rate, but we do need to type bandwidth. That's if your routing protocol needs the bandwidth. Okay. Ooh, what did I forget to do? No shutdown. Right. Up arrow, conf t. Up arrow to find the interface. No shutdown. Hey, green lights. Green lights, both sides. Control Z, WR. If I pop into the service provider router, you should see that the interface has come up on that side too. Okay, excellent. Now, how do I test connectivity across the link? Ping. 88 40 12 2. So from our router we're pinging across the link to 88 40 12 2. 5 exclamation marks. That's 100% success rate. 5 packets sent, 5 packets received. Fantastic. Right, okay. Let's set up some dynamic addressing on our corporate network. I don't want to have to put IP addresses on all of these routers. There's far too many of them. There's 200 PCs. There's 200 PCs on this subnet. I don't want to put IP addresses on all of them. Okay. So what we'll do, on the router, we'll create DHCP pools. One pool per subnet. We will not create a pool for the servers, of course, because they will be using static addressing. So for the sales subnet, the research subnet, and the management subnet, we'll create DHCP pools. What are the network addresses we'll use? They're already on the board. 172.16.10.0, 172.16.11.0, and 172.16.11.64. What are the default gateways we need to use? Again, they're already on the screen there. Okay, let's move that to one side a little bit and start configuring the router. Right. There are 4 subnets. How can I see my subnets? Let's look at the routing table. Show IP route. Okay. You can see our 4 LANs. These are the 4 subnets, the 4 LANs inside our company. 10.0, 11.0, 11.64 and 11.96. Sales, research, management and servers. We also have one WAN which goes off to the internet. Right, we don't need to worry about the servers subnet because that's static addressed, but the other 3 we're going to create DHCP pools for. So conft IP DHCP pool. I'm going to use the VLAN names. VLAN 10. Okay, and we'll give it the network address of, which is the network address for VLAN 10. I can actually see it on the board there. By typing show IP route, I can see the network address. 172.16.10.0. Packet tracer even allows me to copy that and paste it. The subnet mask is /24. Job done. That line will actually hand out the IP address and the subnet mask to the PCs when they request IP addresses. The only thing it won't hand out anything else. So we need to put default router to hand out the default gateway, which for VLAN 10 is 172.16.10.254. And it won't hand out the DNS server either. And our DNS server was 10.10.10.1. Okay, that's it. Job done. Let's just do those a lot quicker now. VLAN 20. Subnet is 172.16.11.0 with a mask of /26, which is 192, with a default router of 11.62 and a DNS server. Luckily that doesn't change at all. Now let's do VLAN 30. Network 11.64. And subnet mask /27, which is 224. Default router of, where is it? It's on the board there, 1194. DNS server 10.10.10.1. Control Z, WR, job done. Show IP DHCP pool. Doesn't have that command, or does it? Hold on. Is it DHCP -pool? Okay, packet trace is very good, but it doesn't have all the commands a real router would have. On a real router you can type show IP Dhcp pool, but we can use the bindings command, and that will show us any IP addresses that have been given out and the MAC address of the machine they've been given to. None have been given out at the moment, so it's completely empty. Right, let's see if this is working. It should be. Next thing to do, we'll go into one of the PCs, go to desktop, go to IP configuration, and tell it to use DHCP. And cross their fingers. And look at that, 172.16.10.1. It's handed out the first IP address in the sales VLAN. It's handed out the correct default gateway, and it's handed out the correct DNS server. Superb. Right, let's try the next one. Desktop, IP configuration, DHCP. This should get 11.1, and it does. The /26 mask, 11.62 for my default gateway, 10.10.10.1 for the DNS server. Finally, last PC, the management VLAN, DHCP, should get 11.65, which it does. /27 mask, default gateway of 94, 10.10.10.1. Let's double check. Bring up the command prompt, why not? I always like to use the command prompt. ipconfig /all. And there's your automatic IP address, subnet mask, default gateway, and DNS server. Superb. Okay, that's all looking pretty good. I suppose, yeah, we'll call it a day there. And in the next video, we'll have a look at getting this internet connection working all the way across. We'll look at connecting straight through to the internet from these PCs. And we'll set up DNS. We'll set this server up as a DNS server, and we'll set it up as a web server as well, and this one over here too, so as we can browse from our PCs using the URL to the two web servers, one on the internet and one on our corporate LAN. Okay, I hope you found that useful, and I'll sign off from this video. We'll come back on the Lab 4 video, connecting to the internet and DNS. Thank you very much.